Hello, I'm Andrew Gerwitz, and I will be talking about nanotechnology today. Okay, I have a couple things that I have to go over. First is going to be what is nanotechnology, how it affects different fields. I will probably stick with biology a lot because I'm studying that one. And then hazards, which is, of course, the opposition to working with nanotechnology. Okay, so nanotechnology, this is anything from 1 to 100 nanometers. That's actually pretty small. You would need a scanning electron microscope to see this. A normal microscope is actually just an electric microscope, so that won't be able to pick up anything this small. Okay, so a couple different things that you'll find if you're ever looking into well, into nanotechnology is going to be biosensors, DNA manipulation, nanobots, nanofactories, and nanofibers. I will get into those in a little bit, but first, I want to show you the different sizes of nanotechnology. Okay, so we'll start off with the DNA. You're never going to be able to see this with the naked eye because it's about 1,000 times smaller than a bacteria, which is roughly the smallest thing you can see on an electric microscope, which is the microscope normal colleges will have. Um, we'll definitely be able to see the large raindrop, which is about 1,000 times larger than that. Next, of course, is this carbon nanotube, which is grown on a nickel plate, but that is 10 or 100,000 times smaller than a human hair. That's huge, or teeny, I should say. And of course, our nanoparticle, a million times smaller than an ant. And an ant's pretty small. Okay, so now let's get into some biology. Um, there's quite a few different things that can be made from nanotechnology. Biosensors, which would be used to target certain cells, such as cancer cells, for pinpointing them and then inducing apoptosis, which is programmed cell death. Nanobots, which would be close to the same thing, they are used, at least for now, they've been used to move DNA, which tells a cell to go into apoptosis. So the cell dies. Almost the same thing with the biosensors, but it's a little different makeup. And the nanofactories, that's something, it it's the same end goal, but it's a different strategy, I guess you would say. What you're going to do with a nanofactory is, because medicine is found to be better using proteins, and the body automatically breaks down proteins, nanofactories will be small factories set up inside your body at a specific site just to create the proteins. That way, that site will have the proteins you need without them being degraded or moved away. And then, of course, DNA manipulation. This is close to the same as nanobots because DNA manipulation is the nanobots. They are small DNA molecules that have been used to, so far, because it is in the very early stage, just take a couple steps. But it's a DNA robot that moves like a human. That is a huge discovery so far. Now, before I start geeking out too much, let's move on. We have some chemistry things. The chemistry about nanotechnology is very interesting because it changes. The physical properties, they don't really change, but the true properties come out, I guess you would say. Like in this vial here, that's actually nanoparticles of gold, which turns a rose color when you get the nanoparticles. This is because the electrons hit it differently. And carbon nanotubes, you wouldn't ever think of anything that's carbon being able to grow, but you grow nanotubes, or you can at least, on nickel plating once it gets to a very cold temperature. I guess next, also, they're much more reactive. Because they have such a greater surface area, everything on the nanoscale reacts a lot more than anything on the macro scale, which is what we live on. Because every surface on these molecules is available, where on ours, it's like the first cube. You only have so much area. Next, we'll get on to engineering, which I'll explain this picture first. It is actually a picture of atoms arranged to spell out IBM. This was one of the first things, actually, it was the first time anybody had manipulated individual atoms to do anything. And they spelled a word with it. Through nanotechnology, you can manipulate individual atoms to where you want them to be. That is our advanced mechanics right there. Other than that would be the new materials, such as more durable resources. That's where the carbon fibers come in, because once you do get each full sheet of carbon fiber, it is much more durable than just regular carbon. And computers have been made, they're not very good computers, but out of just carbon nanotubes, which right now we're using silicon, but that has a certain death rate, I guess you would say, which is why all of your technology just starts to fall apart on itself. Now, if these carbon nanotubes could work correctly, well, they do work correctly. If they could be researched and work better, then we may be able to have longer living technologies. Okay, on to the opposition. Now, there are a lot of problems with nanotechnologies. And the main one being, of course, we don't know enough about them. It's a very new and emerging field. Nobody knows what's going to happen. Uh, it could be easily related to asbestos, where it was a miracle substance until people started finding out it was pretty much killing them. But it also could be a huge jump into the future for everything. Now, one of the main problems that we do know about is that it's really easily taken in by the body, pretty much any nanoparticle. Most studies have found that most of the nanoparticles that we're using aren't harmful, but that's not to say that they're not going to be harmful, or that anything's not going to be harmful. That's why this absorption through skin and this inhalation is very, very important to remember. But without any push to be better, then, well, with any push to be better, there's going to be risks. So I believe it's worth it, at least. I'll leave your decisions up to you. So, that's it. I've covered it all, and I'm done with this.